So we're shifting, I guess, the way we do things with statistics. It's not going to be like no functions, nothing like that, but hopefully you'll enjoy it, enjoy this unit. Okay. So what is statistics? It is not only the collection, it's also the analysis of data, right? Aims to interpret what the data is trying to tell us. That is what statistics is preoccupied with. Yeah. And so just getting a bunch of data is useless if you don't interpret it. If you can't tell what it's telling you at the end of the day, it's useless. You spend a bunch of money surveying people and doing whatnot, and you're not getting what you need, right? So interpreting is the main point. So I'm going to come down to this point, right, where data is at the center. You need it to do anything else. You need your data. You need to collect the information. So it could be, I'm just giving you random examples, right? The height of people, the scores that someone is getting on tests, the IQ level, right? Number of items people are purchasing over Christmas, like average number of items, like you name it. Data could be anything. It could be the number of days it takes, you know, for geese to travel from south and arrive in Canada, right? It could be anything. So data is at the center, and so from the center, we could find what we call, that's what we're going to start with, the MCTs. These are the measures of central tendency. Okay, measures of central tendency. So it basically is trying to find the center. And so the MCTs, whenever you hear that, I'm talking about the mean, which is also known as the average, the median, and the mode. It might have been a while the last time that you had to calculate these, but I'm going to show you how to do it. Okay? We're also particularly concerned with the dispersion of data, the spread. Dispersion, think of spread. How spread out is your data? Is it clustered? Is it spread out? That's going to be a big question we're going to ask ourselves. How does the data deviate from the mean? Deviate is another thing for vary. How does the data vary from the mean? Okay. How is it different? Okay. So we're also going to look at, this is probably one of the main concepts is standard deviation. And I'm sure that if you listen to news or if you look at, you know, the latest surveys or whatever, down the road you might hear these two words, standard deviation. Okay? It measures, it's actually a measure of how spread out data is. Okay? On top of that, we're also going to visually interpret data. We're going to actually graph it, okay, and see what it tells us while graphing it. So there are 4: frequency table, histograms, frequency polygons, and number line, in no particular order. So that's another. So these are basically the 4 camps that we're going to be in across this unit, okay. And the last box at the front here, normal distribution. We're going to talk about that. Okay. So normal distribution, what you want to think of is, this is going to be your x-axis, right? And usually the average is in the middle, also known as, this is new to you, x with a bar on top. X with a bar on top is what we call average or mean. So all 3 of these mean the same thing. Average is the same as x bar. That's a symbol. It's the same as mean. Okay? And what we will notice that a lot of data, kind of the peak of most of our data will fall right where the average is, and then to either side it's going to kind of drop off like this. It's going to be fewer and fewer items that are to the left of it, and same thing on the, if you go to the right, there's going to be fewer and fewer items that are greater than your average. Okay? And so I want you to think of the bell curve. I don't know if you've ever heard of the term bell curve. But there was a major event in history not too long ago in 2020, right? When COVID hit, they said flatten the curve. Remember, we were trying to flatten the curve by having all the restrictions in place. So basically what the government wanted, they didn't want all people to get sick at the same time. They wanted people to get to spread it a little, right? So that you're not all getting sick at the same time. To flatten this curve. The flatter this curve, the more spread out your data is, okay? So that's another concept we're going to talk about in this unit, okay? So think of the bell curve when you think of normal distribution. Not everything is normally distributed, but a lot of things are, okay? So let's dive right in here. So I apologize already. I'm going to bombard you with information today. It's going to be one of those days. Page 2. Okay, so MCTs, mean median mode. What does MCT stand for? Is measure of central tendency. There it is one more time. Trying to find the MCT is kind of like finding the number around where the data clusters, right? The data will cluster around that measure of central tendency. So let's say I do the MCTs for the cumulative test that you wrote, and I find that my average is 60, like my MCT is 60. So I would be like, most tests are around the 60% mark. I'm just making stuff up. I actually don't know what the average is right now. But that's what MCT would be. There are several different ways of to measure the central tendency. The most common one is the arithmetic mean. That's the average. It is called the average in everyday language, right? That's the arithmetic mean right there. Okay? So our mean has the symbols x bar or mu. That's what that letter is, okay? The arithmetic mean is denoted by this symbol, right? There it is one more time. And it is found by adding, you add all the values, and then you divide by the sum of the number of values. Make sure you include units when you do that. So, this is the fancy way of stating the formula of what I just said here. Finding the average is adding up all your values. This is sigma. This is the sigma notation. That means add up all the values you have, divided by n, number of values. So this is number of data points. Sorry, I know it's small. Should have made that box a little bit bigger. Number of data points, and this is sum of all data points. So you would add them all. So let's say your addition is like 2,500. And then you would say, well, how many values did I add? Oh, I added 10. So you'd go 2,500 divided by 10. That's 250. Okay? So that's how average works. And I'm sure you've done that many, many times in junior high. Okay? Median. You remember what the median is? It's the middle value in the data set. Okay? You have to have it in ascending or descending order. This is important right here. I'm going to use a different color for this part. This is the best definition of median. If you find it, half of your value should be below it, and half of the value should be above it. That's when you know you got your median correct. Okay? And then it gets a little trickier. If there's an even number of values in the data set, then the median is the average or mean of the two middle. Make sure you include units. So this is my example. Let's say these are the numbers you've collected. And already 5, 7, 16, let's see. This is an odd number of values, correct? So 5 is your middle. That's your median. No problem, right? But what if you have 2, 3, 5, 11, 16, and 21? There you have an even number of values, right? You've got 6. In this case, you got to grab these two, right? These two are kind of like your middle value. Think about it. You've got 2 that are below, 2 values that are above it. So the median is found in between these two. So in this case, the median is 5 plus 11 divided by 2. Remember, what is average? It's adding up the values and divided by the number of values you're adding. So you're kind of just having a small little zoom in to this area, and the average should be 16 divided by 2, which is 8. 8 units is your median in this particular case. In this case, it's just 5 units. Okay. Can we do that? Median is 5 units. Just to make sure. Don't forget the units. So it could be kilometers per hour. It could be anything, centimeters, you name it. If the question has units, you add it to your, and it's okay to have decimals here. Okay. Mode. Mode is the number that occurs most often, and most popular. Occurs most often in the list. There are 3 options though. You can have no mode if everything appears the same number of times. So I'll give you a concrete example here. If you have 3, 3, 4, 4, 5, 5, you're like, oh, wait a minute, yeah, no, there is no mode. Okay, no mode. This is a common error, right? Common error. Students saying that the mode is 0. Is that correct? No, because then you're saying 0 shows up most often, which is not right. So make sure you put a little X there. That's incorrect. Just say no mode. You could have one mode, right? If one number occurs more than any other number. So I'm going to go 2, 2, 3, 3, 5, 5, 5, 6, 10, 14. I'm just making stuff up here, right? But you're like, oh, 2 and 2. But then you find one that appears most often. That's your 5 here. So the mode would be 5 units in this case. A number of modes, right? That's another option. You could have more than one mode if 2 or more numbers occur the same number of times. Okay? So we have, let's use some negatives here. -3, 0, 1, 1, 1, 7, 12, 13, 13, 13, 17, let's say. Remember, we could find the average, we could find all of those, but right now it's just focusing in on the mode. And you see that there are 3 1s here and 3 13s there. So in this case, the mode would be 1, 13 units. Okay? There's 2 modes there. Okay, I'll say something. I'll stop there for a bit. I just need you to understand that the mean, the median, and the mode all try to find the middle. But they're not always good at it. Sometimes they flat out are not good. You should not be using it, right? For example, if you arrange your data set and you find that your mode is like on the very high side or on the very low side, it's obviously not finding the middle. You should not be using the mode in that case. I will talk about it already, but if there's an extreme outlier, Like if you look at your data and there's like, look at this, 3, 3, 4, 4, 5, 5, and then 1,000. Whoa, right? The 1,000 is like way out there. Then mean is also not a good option because it will include it and it will skew your data. Okay, so we're going to talk about that a little bit more. They all try to do it, but they're not always good at it. That's where you come in. Okay. Mode, I'm just going to make a little note here. Although mode is referred to a measure of central tendency, right, it does not necessarily lie towards the center of the list. Mode is used in different situations than the mean or the median. For example, a store owner could use the mode to find out which size of t-shirt is most popular, right? In that case, you would most definitely want to use the mode, right? Which one should I order the most of? Is it medium? Is it large? What is it? Or shoe size, right? It could be a certain shoe size that the store owner realizes, oh, 8.5 sells the most. I'll order those the most every time. Okay. So mode is used in different applications. Okay, I'm just going to do this on the side here on the margin. So let me just see if I can make, yeah. So I'll just tell you that all of these three here, all the way to the mean, are MCTs, okay? They're MCTs, they're measures of central tendency. You cannot see the mean, can you? Hold on. But I went all the way to the mean. Okay, this bracket includes all three of these, mean, median, mode. Ideally, okay, ideally, you would want all three of them to be sort of the same or close to each other. That's a good sign. You're listening to that, right? If you find that the mean, median, mode are very close to each other, when you calculate them, that is a good sign. You're like, oh, okay, my data is something is jiving here. It means that all three of them are finding the center, and that's a good thing. Okay, let's keep going here. Range. Not an MCT, by the way. Range is not an MCT. So I'm going to highlight that. It is calculated by subtracting the smallest from the largest data set or number in your data set. It will be a measure of dispersion, and it tells us how spread out your data points are. That is what range does. Okay, so I'll just do that right here. If you want a formula, range is the max minus the min. This is not the same as the range, domain and range, okay? It's just, you just have, take the highest value, subtract the lowest from it. And then outliers. Outlier or outliers, values that are significantly different from the general trend. They can cause the mean to either increase or decrease. They also affect the range of data. Okay. So if you see a general trend and then you see one number that's significantly different, we call that an outlier. All right. Let's flip over to the next page. Try to just take it in as much as you can. I will repeat myself quite a bit in this unit because I know it's new to you. Some of the concepts I'm going to be talking about are new, but I hope that after a while you're going to start making, it will start making a bit more sense to you. So go to page 3 here. This is big, and we're going to come back to this page from time to time if you need a refresher. Okay, so standard deviation has that symbol, which is also sigma, but it's lowercase sigma. Okay, and so I call standard deviation, you can look for that symbol or SD. Okay, SD will do it as well. And if you're wondering, how should I do my sigma symbol? I always do one of these. I just go like a 0 and then just put a little squiggle on top. And then you've got it. You've got your sigma, because I use that for standard deviation all the time. Again, what does it do? Standard deviation measures the dispersion or variation within data points. Put simply, standard deviation is the average distance from the mean, okay, of all data points. Another important thing, this can be calculated and will have the same units as the data set. And one more thing, look for this, the sigma x, when performing one variable stat calculations. You're like, say what? Don't worry about it right now, we'll do that in a bit. Okay? So, I'll try to have this both on the screen for now. I think we can make this work. Yeah, there we go. That's what I want. That's what I want. So when we are comparing data sets, we will make a notation of, or we'll make an observation. Is the standard deviation lower or is it higher? Like we're going to compare standard deviations between data sets. So a low standard deviation generally indicates that the range will be low as well. Okay? So the range will be low. If you have a low standard deviation, the range is low. The data points are in general closer to the mean. The data is clustered around the mean. It means these two are saying the same thing, by the way. If the data points are closer to the mean, we know that they're clustered, right? They're bunching up around the mean. Data is known to be consistent, okay? Few or no outliers. That's what consistency is telling us. And this is probably, I'm going to use a color that kind of connects these two here. A lower standard deviation graphically will show a steeper curve. A low standard deviation shows a steeper curve. So, right, this is steep compared to the one you see below, right? It's a little flatter. So you kind of always want the top of the bell, right, to be around the mean. So you can make a line like that. This is the mean right here at the center. That's the average. And your lowest and highest value, you want to do this here at the bottom. If you were to figure out max minus min, we would call that the range. So the range will be smaller, right? Like, imagine this is your x-axis. The smaller the difference between the min and the max, the more compressed your curve is going to be. And so your data points, if I were to collect data points, most of them would be located closer to the mean, which, so technically if you were to make bars out of these points that you've collected and then connect those bars, you would be able to make this bell curve and it would be steeper, okay? So that's one thing, low standard deviation, steeper bell curve, okay? Let's go to the bottom one. If you have a higher standard deviation, I'm going to use a different color for this one. Let's go with green. Let's go with the graphically. What does that mean? A higher standard deviation will show a flatter curve. Okay, so let's actually go on the curve. I know this is very low quality graphing. I know that. I have to use my mouse to make that flat curve. But a higher standard deviation, it means a flatter curve. And why is that? Because Remember, standard deviation measures the average distance from every single point to the mean. So the more spread out you are, right, if you have values even down here on the very low end and very high end, they're more spread out. They're not clustered around the average. Okay, so this is your mean. And your range, watch this. The range is greater. You want to go up here and just say range is smaller. Okay. So graphically, if I told you a higher standard deviation, you would know that the graph would be flatter compared to the other one. So I'm just going to, range is greater as well. Data points are spread out more widely. They are scattered further from the mean. And a data set that has a high standard deviation will show less consistency. May have multiple outliers on either end. Okay? So, if let's say I compared this class to last year's class, September, and I do the math, right? I grab your final marks and I come up with my standard deviation. And I say this, don't write this down. Last year, let's say my standard deviation was 7.9%. And then this year, my standard deviation is 2.35%. Okay, what does that tell me? If I look at this year's, it's a lower standard deviation compared to last year, right? You could say, if you look at this, you could say, well, that means that this year, the data is more consistent. It's closer to the mean, and it's more a steeper curve. Like this graph, if I were to graph it, it would do something like this. If I compare it to last year, it's a much larger standard deviation, which means I probably had a student here and here, or both, or more on the outside, so it's a little flatter, okay? The curve becomes flatter, less consistency here, okay? So that's one thing that we're comparing a lot in this course, okay? All right, let's do some math here, because I know you're loving this, right? And it will take some time for this to settle in. Don't worry too much about it today, just stay with me. And I will find various ways to bring this to life, okay? Here, we're going to use a graphing calculator to find the MCT, standard deviation, and the range. I don't know if this is worth having this whole thing on your study sheet, but I developed these steps to help you out. Obviously, it's way too big. I don't think this is how much space it should take up on your study sheet, but here it is. If I give you a bunch of numbers, and I'm telling you it might be up to 50 values that you're going to have to enter, I would say enter data points into L1, and I think you all know where to get L1 but at this point. It's basically our spreadsheet that we're going to use. Then I would like you to sort the data point. How do you do that? You press Stat, and you'll see the sort A in a bit. I'll talk about it in a bit. Sort A sorts in ascending order. If you choose sort D, it will be in descending order. It doesn't really matter. I just like to sort my data points, which is very, very nice. Okay. Then I would like you to calculate the mean, standard deviation, and the median using stat, calc. We used to do quadreg, correct? Now we're going to use this one variable stat. So that is new. This is brand new to you. Okay. Once you run that thing, you should see this on your calculator. And I will do that with you in a bit. So the most important things, though, on this is the following, okay? This one right here, see the X with the bar on top? That is the mean, okay? Sum of X means like if you were to add up all the values you entered, that's what you would get. We're not so concerned with that. Sum of X squared is like if you were to square all the items and add them up, you get that. Not so concerned. We're also not concerned with this one, but this one right here, we are. This is your standard deviation right there. Standard deviation. I honestly think that this part you don't need on your study sheet. This whole thing, this is just a screenshot, right? Also, this one right here, what does N tell us? I bet you can figure that one out. The number of values you've entered. Pay close attention to this one. Because if you are off, you can tell right away. It's like, wait a minute, I'm supposed to have 50 numbers. Why do I have 49, right? So, number of values entered. That represents the number of values you've entered. Okay, I have to tell you that you will have to use arrow down on your screen to continue seeing more. Okay, so then there's this one, the X min and the X max. That's what you will use to figure out the range. Okay? Use to determine range. And I have that one more time here on 4. The range is you get by subtracting max X minus min X. That's why I use a different color there. And last but not least, which other one do you think is going to be important to us? I don't know if you've seen this, but the median is right there. The median. So all of this is done for us, basically. But I think I'm still going to ask you to figure it out by hand at times. Because when you go to post-secondary, you need that. Okay. Range is max X minus min X. Okay, one more time. In this case, because that's how it's stated. Then number 5, determine the mode or the modes. How would you do that? You go to L1 and you just look through your sorted list. It's now sorted because you sorted it on step 2. And then you just scroll through it and see which one your mode is. That one, unfortunately, is on you, right, to figure that one out. So let's do that right now. I'm going to use these steps, but I'm going to go to my first example here. It says below are the daily highs over a 12-day period during the month of April in degrees Celsius of the 2 cities in Canada. So there's Toronto and then there's Winnipeg. Okay? It says to calculate the mean, median, mode range of the daily highs. So we'll go ahead and do that. We're going to go ahead and enter Toronto into L1 right now. Go ahead and do that with me. Right. Go stat, edit, clear whatever you have in there, and just go ahead and type it in. Oops. So I'm just going to count 2, 4, 6, 8, 10, 12. Supposed to have 12 values. It gives us a hint, right? 12-day period. But I make sure I have 12 values. It should say L1, 12 on the last value. I'm just going to double check. Please do that. I'm going to double check. So 5, 5, 8, 9, 5, 0, 9, 7, 12. Because it's very annoying if you get this wrong. You get the whole thing is going to be off. Okay. Next, we're going to go to L2 and type in Winnipeg. And I'm treating this as a spreadsheet. If I had another city, I would have been entering that into L3. If I had a fourth city, L4. Like I just enter this. So let's enter these values into L2. I go ahead and do that. Just make sure you use a negative, not a minus. Okay, I've entered it. The next thing I do, once you've done everything, I want to sort them. So this is how you do it. Watch. You press Stat, and you see Sort A right there. Second option. Instead of going Edit, you go Sort A. Hit Enter, and you got to feed it. You got to feed it the column to sort. So we're going to say L1. Close bracket, so second one, right? That's what you press. Hit Enter. If it says done, it has gone and sorted it. Do it one more time. Copy, paste. Hold on. Slow down, Mr. Dirksen. You've done this many times. We haven't. Stat, sort A. Second 2 to call L2. Hit Enter, and so now it's sorted first and the second column for you. Let's go check. Stat, Edit, and everything is sorted for you. So it's kind of nice that way. Okay. So it says calculate the mean, median, mode. So we're going to do Toronto first, and then Winnipeg right next to it. So just leave it like that for now. So you basically just want the mean, the median, and the mode for Toronto. Okay? So we go one variable stats, and we're going to feed it L1. Okay? By default, it will take L1. So you're with me, right? So you press Stat. You got to go to Calculate. And do you see one variable stats? It's the first thing. We used to go to quadreg, correct? Never use two variable stats. We're not using it in this course. Always one variable stats. Hit Enter. It comes to your home screen. Go second one. To tell one variable stats, go and look at L1. Okay? Hit Enter. You should see this, 6.83 repeated. So we write down that the mean is 6.83 what? Degrees Celsius. Where do we get? I didn't say standard deviation. Sorry guys. Can you just make sure you put the standard deviation here? We do want the standard deviation. Just add that to your notes here. That is standard deviation right there. Where's our median? You got to keep going down. Median is right there. If you keep going that arrow down, 7.5 degrees is your median. So write that down. We'll get to the mode in a bit. Mode, you have to go to your column to L1 to figure that out. But standard deviation, where is that? Standard deviation is right here where my pencil is. It's 3.21. 3.21 degrees Celsius. Okay? And now let's look at our mode. So we go Stat, Edit. I'm going to go through my L1 here. Let me see if I can zoom in. A little better. And I'm going to check. Oh, I see 3 5s there. So far, that's my mode. And I see 3 9s. Do you see that? 3 9s. So you just scroll through it if you have to, right? And 3 5. So those are my two modes there. So 5 degrees Celsius, 9 degrees Celsius. Okay. I will just say check L1 in this case to figure out your mode. Check L1. And so right beside it, we're going to do Winnipeg. Let's see if I'll give you a minute or two to figure this out. So the mean, the median, the mode, and the standard deviation. Hold it before we do it. Who do you think is going to have the higher standard deviation, Winnipeg or Toronto? Which city has the most wonky temperature ranges? Winnipeg, right? Winnipeg is like minus 40 plus 10 on the same day sometimes, right? So we're expecting Winnipeg to be higher than this. We'll see. Can you go figure it out? So instead of one variable stats L1, what are you going to feed it this time? One variable stats L2. So go ahead and do that and then come up with these numbers. See if you can get it. And if you can't, that's fine. We're still at the very... If your calculators are acting up on you, let me know, right? I'll help you out. Okay, so for this one, just got to make sure I'm doing this so that it's in the video, right? So in this case, you want to feed it L2, and there it is. So it's 0.5 degrees Celsius. We expected that, didn't we? Winnipeg to be colder on average. Our median is right there. That's 1.5 degrees Celsius. Our mode, I'll do that in a bit. I'll first get my... Please don't mix these ones up. Common mistake. It's this one with the little sigma, right? 5.77, sorry, 5.77 degrees Celsius is my standard deviation. And I will do this here. Range. Range is the max minus the min. So I'm going to go to my L2 for that. And this is my lowest, right? Lowest is negative 12. And what's my highest? 9, correct? So I'm going to go 9 minus the lowest is negative 12. That's how that goes. Sorry, my mouse is on there. So this turns into a positive, correct? So it's 9 plus 12. So that's 21 degrees Celsius is separating the highest and the lowest temperature. That's the range of temperature for Winnipeg. Let's go over here. Range for Toronto. What do you think is going to be bigger or smaller? Smaller. Technically, if this is correct, if this is accurate, if I just made up numbers, probably not. But I actually went and looked this up. So let's do the range. I'm just going to go 12 minus 0. 12 minus 0, the greatest. So that's 12 degrees of separation. Now pay attention to this. This is what I want you to see. Low standard deviation, low range, it's less spread out. Okay, so I'll just make a note here. Low standard deviation is going to be equivalent to low range. The data is going to be clustered. Okay, make sure you make that note. Low standard deviation, low range, you're going to have a clustered data set. High standard deviation, high range, it's going to be spread out or scattered. I'm okay with that. Can we do the little bell curve? If we compared Winnipeg compared to Toronto, let's go. Toronto is going to have a dashed line, And Winnipeg is going to be solid. That way you don't have to worry about colors, right? If this is your x-axis, pay close attention to this one. Where would the average be for Toronto? If this is 0 degrees, and this is 10 degrees, let's say. Where is Toronto here in terms of the average? 6.83 is right about there, correct? Right? So that's going to be the highest point for me. That's the average for Toronto. And then you would go like this. It's a steeper curve. The average is 6.83. Let's write that down because sometimes you might wonder what happened there. I use the average to figure out where's the highest point for my bell curve. It's by the average. Okay? So try to copy that as best as possible. I will add colors yet to it. Okay? Where is Winnipeg's average located? 0.5, correct? That's like here somewhere. So is the curve going to be flat or steeper compared to this one? It's going to be flatter. So you just go over here somewhere, and then you just go like this. Whoa, that, Mr. Erickson, I can't handle that. That's too much information. I know. I'll do sides like this. I go off on a tangent quite a bit. But just to get you to understand, okay, this is 0.5 degrees right there. Okay, and so I want you to start seeing that. Okay, let's keep going. Can you stop right now, Mr. Erickson? Be nice, wouldn't it? A bit more. Let's keep going. Right. Page 5. Create a line plot for the temperatures in both cities. Label the mean, median, and mode. Okay. How do I do a line plot? I will use the min and the max to help me find a proper scale. I add labels and units just like before. Place the data points on the line. Stack them if there are multiple entries. This is important here. And then just label your MCTs. Label your MCTs. So I already started this for you. Other than that, you would want a ruler. Go ahead. You would want a ruler. And I'm going to put Toronto on top, Winnipeg bottom. Add as much information as you can. So one of the pieces is make sure you put arrowheads on both ends here of your. So if I give you something to start off, you still need to complete it. Everything is going to be in degrees Celsius, correct? For both of them. I kind of told you already to start at -16. Okay. However, for Toronto, I know that the minimum is 0 degrees Celsius and the max is 12 degrees Celsius. I know that for Winnipeg, and you don't necessarily need to have this written down when you make a line plot. I'm just letting you know how I went about it. The lowest was -12 and the max was 9 degrees Celsius. You can easily go to your calculator and check L1, check L2, and figure it out, especially if it's sorted. So I'm just suggesting let's start with -16, and let's see what works. If I go by 4, so it'd be 12, -12, right? -8, -4, and 0, 4, 8. Yeah, that works. So let's go by 4s. Okay, so it'll be -12, -8, -4, 0, 4, 8, 12, and so forth. I think that's that's good enough. Okay. Let's do the same. I want you to use the same scale for Winnipeg here. So I'm copying the numbers, to be honest here. So just be consistent. I don't care what scale you use, as long as you're consistent, all right? Sometimes it's smart to go up by 2s, sometimes by 1, sometimes by 0.5. You'll have to determine that as you go. Now, grab your calculator. So for Toronto, for example, that's why I want you to sort it. I want you to go through the list and put a dot down for where it belongs. So 0 degrees will go right here. 3 degrees goes approximately there. 5 goes somewhere in here. And how many 5s do you have? 3 of them, correct? So you go 1, 2, 3. You stack them like that. You can put X's as well if you don't like dots. I prefer dots. 7 is right about there. 8 is right on the 8, obviously. And then you've got 9. And how many 9s do you have? You have 3 of them. So you stack it like that. There should essentially be 1 dot for every data point. And I do count, random sometimes. So 12, and that's it. And I'll just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 dots, 12 data points. Perfect. And do you remember the average? What was it? 6.83, correct? So all you need to do is to put an arrow somewhere in that neighborhood and just say that's your mean, which is 6.83 degrees Celsius. These two are your modes. I'm okay you just going like that, because that will show up somewhere. And the median, what was our median again? Was it 7.5? Thank you. So it should be a little bit bigger than 6.83. So the median is somewhere in there. There we go. Close enough is good enough for us. It should definitely be to the right of 6.83 though. So label mean, median, mode, and then you're good to go. Repeat for Winnipeg. So I'm going to go to L2 now. I'm going to my lowest point, which is negative 12. So you put a dot there. Let me just have that on the screen. Negative 12. Negative 7. Where's negative 7? Here or here? It's over here. Negative 5. Negative 1 is somewhere here. 0. 1. 2. 3. 4. 6 and 6. There's be 5. 6 is somewhere here. 6. 2 6s. And a 9. Can you see that it's spread out compared to Winnipeg, Toronto? Right? You can. Toronto would be a bit more clustered here, whereas Winnipeg is like, it's like a flat curve, right? So another way to kind of verify, oh, okay, everything is kind of lining up. I just want to make a note here. Please write this down. The range is 12 degrees Celsius. We already calculated that on the previous page. The standard deviation is 3.21 degrees Celsius. For Winnipeg, the range is 21 degrees Celsius. And the standard deviation was 5.77 degrees Celsius. I will say steep, clustered, This will be more flat, spread out. We're not done yet with Winnipeg, right? I forgot. What did I forget to do with this one?
Oh,
Label.
yeah.
Label your MCTs. Your average is 0.5, correct? So it's right about there. That's your mean. 1.5 was the median, correct? Let me just check. Yes, 1.5. So somewhere in there. Thank you. And the mode, right here. What was the mode again? Feeling like it's 6? I just realized that I didn't put the mode down on the previous page. So I have to do that yet. We're almost done. Now, this is the part that you're going to struggle with the most at first, this part right here. Describe the data set for each city using the statistical reasoning. So you can use mean, range, standard deviation, and you can come from either city's perspective, I don't care. So if you were to go with Toronto, right, you can say this. Talk about the mean first. A greater mean indicates that temperatures are warmer than Winnipeg on average. So on average, we're counting it to be warmer. We're almost banking on that. Not every day. There were days where it was colder in Toronto than in Winnipeg, but on average, it's going to be on the warmer side. Okay. It's talking about the range. The range and standard deviation are lower than Winnipeg. What does that tell us? This indicates, use your own words, yeah. This indicates the following. I'll put that right here. Data is more consistent. Closer to mean. Data's more consistent. It's closer to the mean on average. Curve will be steeper. Data points. Sorry. But thank you. Data points are closer to the mean. From Winnipeg, from Toronto's perspective. From Winnipeg's perspective, A lower mean indicates a lower temperature. Right? When you come from Winnipeg's perspective, a lower mean indicates a lower temperature on average. A greater range and standard deviation indicate exactly the opposite of these three bullets here, right? It would be the exact opposite. Data is less consistent. Outliers, possibly. Curve is flatter. Let me just bring that. Curve is flatter. Data points are further from the mean. Okay, I want you to try pages 6 to 9. You're doing this kind of stuff. You're learning how to find the mean, median, mode, range, all those things. You're learning how to make a line plot. And it's just basically familiarize yourself with where is everything on my calculator? What do I need to press when, right? To be honest, arranging is very important because arranging helps you with your graph. I know it's a lot. Thank you guys. I'll see you tomorrow, okay?